Hello, welcome to the shed. On the bench I've got a Bally solenoid driver from Stern Stars machine. No real actual fault with this board, but because I'll be upgrading or changing over the fluorescent display units to LED units, I wanted to increase the 5-volt circuitry from a 3 amp regulator to something capable of handling higher current, potentially up to about 5 amp. And there's a couple of ways of doing that. At the same time I'm upgrading that, I'll look at replacing some of these headers that are looking a bit worn, and replace this main capacitor as well. So that's about the size of the task on the table. The regulator I'm going to use, I've actually got one of these Pololu items. It's a small switch mode regulator, and so these units here is a preset 5-volt switch mode regulator with a 5 amp current carrying capabilities. So it's a step down regulator only. So as we're stepping down from about 12 volts coming into this board, stepping it down to 5 volts, I think these would be an ideal replacement for this linear regulator. One of the benefits of moving from a linear regulator to a switch mode regulator is that there'll be negligible heat generated from this unit here, so we could just do away with this heatsink. So this heatsink and this regulator, this TO3 package regulator, can all be replaced with this little circuit board, and I'll take you through the steps doing that. The rest of the board looks pretty good. I've not had any troubles with the 5-volt rail. It's a little bit low. It leaves on the test point here at 4.9 volts, which is okay. I'd sort of rather them be up a little bit higher than that. I haven't seen what this thing's set to, what its voltage is, but we'll soon see that. But yeah, I'll come back when I've had some progress. Right, well here we are looking at the Bally solenoid driver board. I've removed the old linear regulator and the heatsink and replaced it with the Pololu step down voltage regulator. So this one's item number 2851. So it's a 5-volt 5 amp switch mode regulator. So I've got a little nylon post under there, and I'm going to use some double-sided tape soon to stick that down there. Some VHB tape, that should be nice and secure for that. Now to complete this mod, I've also had to remove R49 and R50, and instead of R50 we've got a link wire there. So it's just remove R49 and replace R50 with a link wire. I also replaced the main filter capacitor, which is C23. Originally on the circuit diagram 11,700 microfarad. I've replaced it with a 15,000 microfarad, a good quality Nichicon unit. I've put the old capacitor on the ESR meter, and it's still showing in pretty good condition. Like there's really no signs of this capacitor having any problems. But I think you'll find that's a date code on there, 10th month 85. Someone's replaced this in the past, about 1985. It looks a bit old and crusty. It's time to replace it. So. On the flip side of the board, oh sorry, one more thing here. I've replaced these header pins with nice gold contact header pins. I wouldn't mind finding some of these long form header pins, but I'm just using the standard short 0.1 inch single line header pins at the moment. On the flip side, what I've done here is I've installed the two recommended mods for this Bally driver board. One is to a mod for the ground, and that's I've done here, and the other is a mod between TP1 and TP3 for the 5-volt rail, which I've done here. Put those 2 wires in. I spent a fair bit of time just cleaning, and as I typically do nowadays, I spend a fair bit of time removing solder from the board. Seems to be a bit of a trend, or at some stage there was a trend for people to reflow header pins and just put too much solder on there. So I've gone through and removed a lot of solder from the board. You need enough solder to do the job. You don't need too much. This board's got a fair few scratches underneath as well. I've been through and inspected them under a microscope. They all appear okay. What I have done is applied some clear nail polish over where the solder resist has been scraped off. So just to give the bare copper a little bit of protection. So on these mounting boards as well, I've actually tinned these. The original board has that as bare copper. So I've given them a tinning with solder, and they should make a good contact now for years to come. So it's time to put it back in the pinball machine and see how she fares. I have measured the voltage coming out of this. It's just a whisker under 5. I'd prefer them to be just a whisker over 5, but at the end of the day, it's just numbers, and so long as we're not in the danger zone by the time the 5-volt gets to the CPU board, that should be fine. But I'll review that when I get there. So here's the schematic of the original 5-volt regulator. Pretty simple. A couple of adjustment resistors there, R49 and R50, and just some filter capacitors. And here's the modified circuit. You can see we've taken out R49 and 50, and the regulator's been replaced with the Polar Lu switch mode regulator. So here we are back in the machine. I've got the meter set up, 4.94 volts. As I said before, a bit lower than I was hoping to get out of the device. I'm trying to track down the schematic for this switch mode supply to see if I can adjust the reference voltage and sneak that up to just a little bit above 5. The machine's operating fine. That's the DC reading, 4.9 volts, and if we click over to AC here, I've got negligible. That's down. That's less than 1 millivolt of ripple on the 5-volt line. That's spectacular. That's very good indeed. Let's go over to the CPU board and see what we get over there. All right, 4.84 on the CPU board, definitely lower than what I'm wanting. I've still got to replace the Molex connectors on the CPU board. This is the headers and the connector here. I've still got to replace the connector here, so I'm hoping that that'll come up a little bit. 4.8, that's okay, it's inside spec. Have a look at the AC reading here, and we've got about 36 millivolts of ripple current there, and that's good. That's still a long way below. That's orders of magnitude below where we start to think there might be problems. So all in all, I'm pretty happy with the switch mode power supply, and we'll come back and have a look when I get some new Molex connectors on. As a side note, you might notice the modification to the 240 volt power here. So in Australia, 240 volt power, I've rewired the powering on this thing. The input AC comes in here now, and I've routed that through a grommet into the steel cage to the transformer. So I've actually removed the 240 volt from the rectifier board and the harness wiring. So all of the 240 volt wiring now comes in on this insulated 3-core flex, and that comes from the switch box. I've installed a die-cast aluminium box around the switch, and put the line filter inside that aluminium box as well. But this comes up here into the cage, keeps the 240 volt, the live AC, away from this board here. Admittedly, we do still have pretty high voltages there to drive the vacuum fluorescent displays, but I'm hoping after I've upgraded these displays to LED, I can remove that as well, so that this whole area here becomes a lot safer. But I've been very, very uncomfortable having the 240 volt fuse here, and which is just open and exposed. Alright, I've had the machine powered on for half an hour now, and just as a demonstration now of one of the virtues of the switch mode power supply, ambient temperature in here about 26 degrees, but the power module fluctuated 37 degrees. So really that's a good result. That illustrates that the unit has absolutely no need for a heat sink. It's coping with the normal flow of operation here, and just maintaining 36 degrees is great.